So, negative areas, which makes no sense because there's no such thing as a negative area, but here we are. So we've looked at finding the area under a curve, but there is a problem that occurs if we have kind of a negative part of a graph, so underneath the x-axis. The issue being if we were to just integrate it normally, so in this case between 0 and 2, these two areas are the same size. Like the area of this is the same area as here. They are congruent. So if we were to integrate between just 0 and 2, just straight integration, the issue we'd have is that, what would the issue be? It would be that this area would be positive and this area would end up being negative. They'd cancel each other out and it would tell us that we have an area of 0, which is clearly not true. There is an actual physical area there. It's not an area of 0. So we have to adjust our method slightly in order to counteract that. So what we do is we find the area of this bit. We find the area of this bit and we ignore the fact that it's going to tell us it's negative and we just make it positive and we add them together to get the total area. So we are going to, I need to expand this bracket out. I don't want to find it. I can't integrate that as it is. So it gives me, I should have done this before, x squared minus x minus 2x minus 3x plus 2, and then multiplying that by x gives me x cubed minus 3x squared plus 2x. Okay, and then I'm going to integrate that. First, for the positive area, so between 1 and 0, so I'm integrating x cubed minus 3x squared plus 2x dx. That would give me x to the power of 4 over 4 minus x cubed divided by 3, so just x cubed. Oh, this is nice. X squared divides with the 2, leaving me with just x squared plus x squared. And again, I'm going to integrate that between 1 and 0. That gives me 1/4 minus 1 plus 1 minus 0. I substitute in 0, so that's just 1/4. And then if I did the same thing with 2 and 1, obviously when I integrate it, I get the same thing. So I'm integrating the same curve, just with different limits. So I still get x to the power of 4 over 4 minus x cubed plus x squared, but this time I'm evaluating between 2 and 1, which gives me 2 to the power of 4 is 16 over 4 is 4 minus 8 plus plus 4. So that's going to make 0. And then 1/4 minus 1 plus 1. Yeah, 4 minus 8 plus 4 is 0. Minus 1/4 equals negative 1/4. But we're going to ignore the fact that that gives us a negative value. And we're just going to do 1/4. So the total area is 1/4 plus 1/4, which is 2/4, which is 1/2. And that's it. Okay, so I've checked the past paper questions. They've always given a diagram. They don't necessarily always give you the roots, but they've given you a diagram to work from, so you can see quite clearly if you're going to have to deal with this problem, because it is a problem. So we're getting a negative area. So you can see quite clearly from the diagram that they do give you if you're going to have to kind of break it up and integrate it in different sections almost. Yeah, but it should be quite easy to spot in an exam. I've got one question. Again, this was the test your understanding question on the PowerPoint. So if you want to pause and have a go yourself before seeing the answer, now's your chance. We've got figure 3 showing a sketch of part of the curve C that has equation y equals x plus 4x minus 2. The curve C crosses the x-axis at the origin 0 and at the points A and B. Write down the x coordinates of point A and B. So that's quite easy. The equation's already been factorised for us, so it's going to cross at -4. So the coordinates would be -4, 0 and 2, 0. So A is -4 and B is 2. The finite region shown shaded is bounded by the curve and the x-axis. Use integration to find the total area of the finite region shown in figure 3. Okay, so again, the first thing I'm going to do is expand my bracket out because I can't integrate it when it's in this form. So I get x squared, I'm going to have 4x and a minus 2x makes plus 2x minus 8. Multiply the x in, gives me x cubed plus 2x squared minus 8x. And then I'm going to integrate. So I'm integrating between, I'm going to do 0 and minus 4 first. X cubed plus 2x squared minus 8x dx gives me x to the power of 4 over 4 plus 2x cubed over 3 minus x squared minus 4x squared between 0 and minus 4. So that is going to give me 0 for the first bracket minus 4 to the power of 4 is 256 over 4 is 64. So I have 64 minus 64 times 2 divided by 3 is just 128 over 3. Leave it as that for now. Minus 4x squared. 16 times 4 is 64. Is it minus? Yeah, 64. So the 64s are going to cancel each other out. This positive, this negative, and this negative are going to make it positive. So I get 128 over 3. If I do it again between, 2 and 0, x cubed plus 2x squared minus 8x dx. Again, integrating it gives me the same thing. I get x to the power of 4 over 4, 2x cubed over 3 minus 4x squared. I'm evaluating between 2 and 0. So this time I get 2 to the power of 4 is 16 over 4 is 4 plus 8 16 over 3 minus 4 16, and then again that's going to be 0 because I'm substituting 0. That gives me 4 plus 16 over 3 minus 16 is negative 20 over 3. I am again ignoring the fact that it is negative, and to get the total area, I'm going to add those two things together. 128 over 3 plus 20 over 3 plus 20 over 3 gives me 148 over 3. Not convinced that's the right answer. I feel like you've made a mistake. Can I just check? Oh, no, it is right. 148 over 3. Yeah. No, that's right. Yeah, that's it. Yeah, and like I say, from my investigations, when you're doing this on an exam, they do give you a diagram so you can see if there's going to be a negative area that's going to cause an issue, and you can then adapt your method accordingly. I hope that makes sense. Did I have? No, I didn't. Yeah, I hope that makes sense. Thanks for watching. Thanks for listening. Have a lovely day.